In this problem, it asks for k over g of x, which means we need to find an equation in terms of x by taking the polynomial k of x and putting it in the numerator, and the polynomial g of x and putting it in the denominator. This gives us 64x cubed plus 1 over 32x cubed plus 16x squared plus 2x. However, this is not simplified. There's common factors that we can factor out and reduce. So we need to start by factoring the numerator and the denominator in search of our common factor. As we continue to solve this problem, we notice that when factoring the 4x cubed plus 1 cubed, this is the sum of two perfect cubes. Recall that we have a formula of a cubed plus b cubed is equivalent to a plus b times the factor a squared minus ab plus b squared. Identifying a to be 4x and b to be 1, we can continue finding a times b to be 4x and a squared to be 16x squared and b squared to be 1. When we're finished factoring our cubic, we will have 4x plus 1 times 16x squared minus 4x plus 1. When I factored the denominator, I noticed that there was a common factor here of 2x. So I factored the 2x out and then saw that I still had a quadratic left. I continued and factored that to be 4x plus 1 times 4x plus 1. You'll notice that 4x plus 1 in the numerator, 4x plus 1 in the denominator gives us 1. This means we have a final simplified fraction of 16x squared minus 4x plus 1 over 2x times 4x plus 1. Now you'll see that they also would like us to figure out what k over g of negative 1 is. So they want us to put in the value negative 1. Which means we need to replace all of our x's with the input value of negative 1. And then simplify this expression. So as I continue, plug in the value negative 1 and simplify the numerator and the denominator, I get the fraction 21 over 6, which reduces to 7 over 2. So that's the second part of the answer. The first part was our function simplified here, and then once you put in the negative 1, k over g of negative 1 gives you an output of 7/2.